So for section 4.3, we're going to talk about measuring variation. And last week we talked about it a little bit by looking at graphs. We could see the spread of the graph, and we could see whether it was low or high. But remember I told you we kill it really, variation isn't important unless you're comparing it to something. So we need to be able to compare it, and to do that we're going to calculate some values. Range, the 5-number summary, and standard deviation. And the first thing we're going to look at is standard deviation here. So we have two banks, Big Bank and Best Bank. And at Big Bank, we have 3 lines for 3 tellers, and you get in line and you wait, for the next person to go through. And sometimes you'll look to the left or look to the right, and you'll see that lines are going faster and some lines are going slower. Whereas at Best Bank, we have a single line and 3 tellers, and then you go to the next one as they become available. And so people come and go, but if there's somebody staying at a slow line, the other 2 tellers move faster and take care of the slack. So, and what they calculated here is they gave you a sample of wait times, for Big Bank and for Best Bank. And we see that the mean and median are both 7.2 for both banks. So you're like, well, great, the average wait time is exactly the same. Unfortunately, at Best Bank, you have some people who are waiting 11 minutes. And some people who only take 4 minutes. Whereas at Best Bank, we have, it goes from 6.6 to 7.8. So when we look at the graph here of the histogram, we can see that it's much smaller, the range of values. They're much closer together than they are here at Big Bank. Okay, and this is variation. All right, and we want to actually be able to calculate. We want to have a number because it's great to have a graph, but we don't always have a graph. So it's nice to be able to have numbers so we can compare them. And so we have this thing called standard deviation, and it gives us a single number to describe variation. It's got a bunch of steps though, so it's not something you can just quickly, easily do by hand, but we can do it on the calculator, on the computer, on the calculator very quickly. So this is what it does. We find the mean. Then we subtract the mean from every data point. So we're going to have positive and negative deviations from the mean. Okay. Now, notice in step 3 we're going to add them. Well, if we were to add them now, we would get 0 because we have positive and negative deviations. So to remove the negatives, we square them because remember, squaring a negative times a negative is a positive, so we have all positive values. So that's why step 2, we square the deviations, and in step 3 we then add them. Then in 4 we divide the added values, the added sum, by the total number of data points minus 1 because we have a sample. If we'd had the population, we would just divide by n, but because we're doing a sample value, we want to make sure there's a little more space to include things that might be incorrect. So that's why we subtract 1 before we divide. So then we take that value and we take the square root of it because we want to get back to, we want to undo the squaring that we did. So that whole 5-step thing looks like this. Standard deviation is equal to the square root of the sum of the deviations from the mean squared. So we take the deviations from the mean, we square them, then we add them all up. Then we divide by the total number of values minus 1. So we're going to see a formula of how to do this next here. And here they say, this is just the whole thing again, in finding the standard deviation when dealing with from a sample, one part of the calculation involves dividing by the sum squared and minus 1, but if we're using the population, we don't subtract 1. That's all this is saying here. The other thing that they're saying is that in step 4, before we take the square root, we have what's called the variance. Okay, and it's used in advanced statistics. It doesn't get used in basic statistics, so you don't really need to worry about it too much, but it does occur. And it's things we can test with the variance, but we don't need it at the moment. But they may ask you what is the variance. It's just the step before you take the square root. So let's actually show you how they're going to calculate the standard deviation. And they're going to do it here for Big Bank. And it's a bunch of steps. So the first step is we have all our values. We are going to subtract the mean from those values. That's what this is. Here's the mean of 7.2, 4.1 minus 7.2, 5.2 minus 7.2, all the way down to 11 minus 7.2. We have all of our values. That's step one. Step two, we're going to square them. So here in our third column, we've squared all of our values. We got rid of the negatives. Okay. Now we're going to add all those up. Ta-da! We added them up. Sum. Now we have to take this sum here, divide by one less than how many things we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 things, so we're going to divide by 10. Alright, 38.46 divided by 10, we get this. Now that's our variance. We now need to get the standard deviation, which means we're going to take the square root of it. So the square root is, we use our calculator, we get 1.96. Because remember, we had one significant digit here. We need to have two significant digits in our answer. So our answer is 1.96. And what is it? It's in minutes. So make sure you put that in there. So they've actually done all that calculation out by hand. Excel has a quick thing to do. It's a formula you can use to calculate the standard deviation once you have a column of numbers, and you don't have to do anything else. But we're going to show you both things, and I'll show them to you in class Tuesday. So here's a rule of thumb using the range, which we haven't shown how to calculate yet, but the range is just the largest number minus the smallest number. And the standard deviation, is approximate standard deviation, is the range divided by 4, because we have two standard deviations to the left of the mean and two standard deviations to the right of the mean. So that's where the 4 comes in. Because we're going to get into something where we talk about what is standard deviation, how is it used, and eventually when we deal with normal probability, we get into that. We start talking about that. So our range, we take our range, our highest and lowest values, and divide by 4. That'll give you just a guide. Okay, if you're not near that, then you've made a mistake. And here, what we can do is they're saying, well, if we've only been given the mean and the standard deviation, our lowest value should be close to the mean minus 2 standard deviations, and our highest value should be approximately equal to the mean plus 2 standard deviations. Notice the 4. So if we have outliers, then it's obviously not going to work. But that's neither here nor there, and that comes up later. So another thing they're talking about when we have the mean, this guy Chebshev's, he had a theorem that says that at least 75% of all data is within 2 standard deviations of the mean, and at least 89% of the data is within 3 standard deviations of the mean. When we look at normal distributions, we're actually going to get even more than that. 95% of the data is within 2 standard deviations of the mean, and 99.7% of the data is within 3 standard deviations of the mean. So this is actually a low ball, but they're saying, if we looked at every sample we've ever done, this should be pretty close. So, and here they're going to give you the range rule of thumb to get an approximation. So we had 11.0, which is our maximum, divided by our minimum, which is 4.1. So we get 6.9, and we divided that by 4. We get about 1.7. Well, we calculated the standard deviation to be 1.9, so we're close. It's not perfect, but it gives you a nice, quick, way to calculate it. So, all right. The range here, they said, all right, well, here's a problem, all right, where we're estimating the range. We have gas mileage of 22 miles per gallon, the standard deviation of 3. So 22 minus 2 times the standard deviation, so 22 minus 6 gives us 16, and 22 plus 6 gives us 28. So we should get within 16 to 28 miles per gallon on our BMW. That's using that estimated range. So that's how we can use those things to help us out. The summation notation for standard deviation, S is the sample standard deviation, and that is equal to the square root of the sum, sigma, parentheses, x minus x bar. Remember, x bar means sample mean squared. So we're going to take all of our x's, which are the values, the data values, subtract off the sample mean, then square them, then add them all up, and divide by n, which is the number of things, minus 1. And then take the square root. So that's what it's doing. If we were dealing with the population, instead of an S, we would have a sigma. And instead of n minus 1, we would have n. So we'd say sigma is equal to the square root of the sum of x minus, really now, we might even have mu in there, squared over n. Okay. And here again, they're saying that the variance, which is not something we're going to use in this book, but you may have to calculate just because of the fact that you have to get to it, calculate to get to the square root. So they might ask you that part, but they're not going to do any testing with it. You know, s squared is the variance is equal to the sum of the squares of the x minus x bar all over n minus 1. So that's all variance. Now we're going to talk about other things. Range. As we said before, the range is the maximum value minus the minimum value. Pretty easy. We can calculate maximum values and minimum values in Excel and have them subtract them. You know, there's a max formula and a min formula, and we subtract them. It's very that's all you would have to do to find the range. Just a list of numbers. But usually we put them in alphabet and numerical order, and then we can find them easy. But you know, a lot of times they aren't. So. Other things we look at. Remember we were talking about the 5-number summary. Well, we have quartiles. And quartiles are percentages. Well, we talked about the median, which is the second quartile or the middle quartile or the 50th percentile. Okay. The lower quartile is the 25th percentile. And the higher upper quartile or third quartile is the 75th percentile. So we use those to calculate our 5-number summary. And again, it gives us a little graph, and we can pick those pieces out. And so here they're saying, well, we had 11 things. So the midway point, you know, 5 below and 5 above the median was 7.2. Well, now when we look at, you know, here we have 5 values. The middle point, 2 below and 2 above, we're looking at the median of the median, really. So 2 below and 2 above gives us the first quartile, and 2 below and 2 above gives us the third quartile. So we take our quartile values and we cut them in half and find the median of those is really what's happening. And there's a bunch of ways that people do this, and there's no one best way. Sadly, there's not a lot of agreement on the first and third quartiles of how it's calculated, but I try to find the easiest way, and that's you know, usually what I do. So your answers might be a little different depending on what process you're using. That's all that's saying. We take our 5-number summary, which is our low value, our first quartile, our median, our third quartile, and our highest value, and we put them down. And that gives us our 5-number summary. And again, allows us to see, you know, variation in the values very quickly. We can then create a box plot, or just a graph from these values, 5 values. We take the 5-number summary, and you know, notice they've made a number line. All right. And then we draw the lines at the minimum and maximum values. Then we draw a line at the first, second, and third quartiles, and we make a rectangle that connects the first to third quartiles. Right. And if we had outliers, we would see asterisks in these. Okay. This one doesn't have asterisks, so it's not a complete box plot, but you know, we would have, if there were outliers, we would see a little asterisk, and those would be considered for outliers. Percentiles, this is where the fuzziness comes for the quartiles, because we're really calculating percentiles. All right, and so the nth percentile shows us how far away a number is, from this value separates the top and the bottom pieces. Okay, so if we have a number that we're looking at, we want to see how many numbers are less than that value. And we divide by the total, and that will tell you the percentile of a value. And they're going to show you an example here. The reverse of that is if we want to find out what percentile a number is, we're going to say, okay, well here they're looking at the 12th percentile, so and we have 50 values. So we take our 0.12 and multiply by 50. The 12th percentile should be somewhere around the 6th value is what they're looking at. And so it kind of allows you to go back and forth between them. And so here's a big long list of numbers. We have 50 smokers and 50 non-smokers, and they are looking at cotinine. I don't know what that is, but I had it explained to me in nanograms per milliliter. So they looked and they said, okay, well, gee, they had them in order here. The first number, the smoker has 0.08, nanograms per milliliter, and the non-smoker has 0.03, so that's the lowest one. Whereas the highest one for smokers is 983.41, and non-smokers is 61.33. So obviously non-smokers have less of this stuff. All right, but what does that tell us? We want to look at percentiles here, and they ask us some questions about it. So what is the percentile of data? What is the 104.54 nanograms per milliliter for smokers? Well, 104.54, that is the 35th number here. So what we're going to do is we're going to find out how many are less than that. Well, how many are less than 35? 34. All right. So that's this number divided by 50 and multiplied by 100. So this number here, this 104.54, is the 68th percentile. The 35th data point marks the 68th percentile is what they're saying. The next one here, they have the 61.33 milligrams for non-smoker. I probably should say for non-smokers. So here, the 61.33 nanograms per is the last one. Well, 49 values are less than that. So 49 over 50, this value, even though it's the highest value, is only in the 98th percentile. Okay, because there were 49 values below it. Not all the values are below it. Okay. So the last one says, question is, what data value marks the 36th percentile for smokers and for non-smokers? So we want to find the 36th percentile. Well, they do 0.36 times 50 because there are only 50 data points. That gives us the 18th value. And if we look at our 18th value on our chart, here they are. They are 20.16 and 0.33, which is what they wrote down. So that's how we find percentiles. If we were looking for the 25th percentile, we would look for the 20.25 times 50. We would get 12.5. So it's going to be somewhere in here for each of these. And the median would be somewhere between 25 and 26. And the median, the third quartile, would be somewhere between 37 and 38. So that's where fuzziness comes in, in these. So whereas if we were looking to say, okay, well, gee, 25, here's when we cut these in half, that's our median is still going to be between 25 and 26, but now I have to find a value where I have the same number equal, so I have 13 because I have 12 below and 12 above versus the 12 and a half, which I could find. And I would have 38 because I would have, 37 where I would have 12 below and 12 above. So that's where the fuzziness comes in of, which, way are you going to do it. And it just depends on, ease of doing it, really.